All right, we're taking a look at 7.4 and 7.5, where we're looking at proportions and similarity between triangles, and more importantly, right triangles that have a right angle inside of them. Also, be sure to maybe even look back at the PowerPoints put into Blackboard. But the major thing from those is going to be these ratios here that you can see. It's kind of an easy kind of go-to. It seems complex now, but we're going to break this down into geometric mean, which is going to be what you're doing with all of these ratios. So the geometric mean in this first problem, right, we have 3 is to x, something we don't know, as x is to another given side of 12. And so we cross multiply, we get x squared equals 36, take the square root, and we get 6 is the geometric mean. And so this is what is kind of happening here, right? And so if we kind of look at what's happening, so m is to c, and then we have c is to v. So if we look at these two separate triangles, so within this larger triangle on the outside, we have this smaller triangle and this smaller triangle as well. They all have a relationship with each other. And so at the base of this is that both of these have a right angle here. And so M and C are both legs for this specific triangle. And then for this larger triangle, we have also the legs. So that's kind of what's happening here. And that's exactly what we'll be doing for the rest of these. So we can set this up here. I even set this up a little bit differently. That x over 3 is equal to 15 over x. Cross multiply, x squared is this. And then we just have to remember how to simplify radicals. So I break this down into a perfect square and square root of 9. And what times 9 is 45? I take the square root of 9, I get 3. I cannot take the square root of 5, and we are done. And then we're back to it again. 4 over x is equal to x over 16. Cross multiply and solve. And so this is what's kind of happening here. All right, we're finding the geometric mean between 3 and 7, right? But a visual representation of this, so x represents a side that is in both of these triangles, the smaller triangle here on the right-hand side and the second largest triangle on the left-hand side. So x is to 7 as 3 is to x. Cross multiply, we can't reduce it, so there we go. And then here is kind of like what I had highlighted down below about C. We need to add 7 and 3. This is where I get this 10. And we're looking at the larger triangle here. And so we're looking at this, and so we can say 10 is the hypotenuse, right? And y is the hypotenuse for the smaller triangle. So 7 is the leg, y is the hypotenuse. But in this one, y is the leg, 10 is the hypotenuse. So we cross multiply, we get 70, y squared. We can't simplify the square root of 70. Here in this one, we're given that this information is 8, and this entire thing here is 20. So if this is I don't know, then this must be 20 minus I don't know, because the whole thing must be 20. So if this was 5, then this would be 20 minus 5, 15. 5 plus 15 is 20. So that's kind of how this works when we're given an unknown, but we do know the total. And we're going to set this up exactly like we did before. So x is to 8 as 8 is to 20 over 20 minus x. Cross multiply. So we are going to have a quadratic formula here. So we're either going to have to factor or you're going to have to use a quadratic formula. And for those of you that have listened to me and used that link to program the calculator, you are on easy street right now. And so I just move everything over. Since this is a negative, I just move it over to the right, makes it positive. Moving this over makes it negative. Plus 64 equals 0. What times what is positive 64 adds together to give me negative 20, which is negative 4 and negative 16. Or I go through this process of the quadratic formula, and you see I still get 4 and 16. And we look here, and it's like 4 and 16 both work. So, but what is, x is obviously a shorter distance. So I picked the shorter distance between 4 and 16. So my solution is 4. Here we're finding the geometric mean, same as the one before, except this one has a fraction. So x over 2/5 is equal to 40 over x. Cross multiply, I get x squared equals 16, taking the square root, and I get 4. More of the same here, we're just simply writing ratios. So x is to x plus 2 as x plus 2 is to x plus 5. And so I just kind of highlighted this to show that we have to add this whole side together, and that's where that came into. Then we cross multiply. Here we have to FOIL, so we get x squared plus 2x plus 2x plus 4. Add like terms and solve. Luckily, the x squares cancel and we don't have to worry about factoring or the quadratic formula. The rest of these are just simply setting up ratios, cross multiplying and dividing. So I've highlighted the ratio here, so it makes it a little bit easier to see where what came from. And then we cross multiply and solve. Here, the same. Set up our ratio, cross multiply and solve. Here we get a decimal. Here, set up our ratios, cross multiply and solve. Make sure we distribute here. Here, set up our ratio, cross multiply and solve. Set up our ratio, cross multiply and solve. Here we have, it's asking for a simplified fraction. We can't simplify it, so we're done. Here's our ratio, cross multiply and solve. And here we're just kind of looking at what is similar to the proportion. So A is highlighted here. AB is to PE, so this kind of part of the triangle. So it's a mirror image basically. So AH to HE or EH. And make sure you use the capital letters here. I think it marks it wrong if you use. And then here, 600 over 310 is equal to 900 over x. Cross multiply and solve. And then here's kind of a cheat sheet of making these ratios.